All right, you mathletes, let's see how to graph a rational function. So in the last one, 4.2, we looked at the properties. So now let's kind of stick everything together and get the graph going on these things. So they're going to come from that parent function of, that should be f of x, is 1 over x. So then label any asymptotes and also intercepts. Okay. So let's get the vertical asymptote first. So the vertical asymptote is what makes the denominator as 0. So in our case, that's going to be a positive 2. So when you draw the asymptotes, it's just a dashed line for any kind of asymptote, vertical, horizontal, or oblique. All right, so you have a horizontal or vertical asymptote right at 2. The horizontal asymptote, the denominator has a bigger degree than the top. So you have a horizontal asymptote right at 0. So it's coming from the parent function of 1 over x. So 1 over x, remember, looks like this. It has the two split pieces. So we got to figure out where the pieces are going to go. Sometimes it looks like this, sometimes it's upside down, other times it's been shifted over left or right. We just got to figure out where. So to do that, a lot of times what helps is getting the y-intercept. The y-intercept kind of anchors things down and kind of tells you where everything else is going to fit. Because I need to find out if the curve is going to be up here, going this way, which means the second curve would be down there, or is it going to look like this? Is the curve down here and the second one above? So if I find my y-intercept, if I plug in 0 for x, my y-intercept is actually at -0.5. Well, if it's down there, that means my curve has to go through it, just like this. Which means the second curve has to be up there. And there's no x-intercept for this one. Nothing makes that numerator a 0. Okay, so not too bad. All right, moving on to part B. -3 is what makes that denominator a 0. The degrees are equal on the numerator and denominator. So that's going to be the ratio of the leading coefficients. So 1 over 1. So you have a horizontal asymptote right at +1 on the y's. All right, so now let's see which way the curves are going to go. Is it going to be like this, or is it going to be like the one that we just drew? So if I find my y-intercept, that'll anchor it and tell me. So if I plug in 0 for x, I get 0 over 3, which is 0. So my y-intercept is right there. Well, if it's right here, that means I have to have a curve that goes through it. So it has to be down like this, which means the second curve is going to be up here. And there you go. All right, moving on. Part C. You have a vertical asymptote at 1. Oops. Didn't mean to do that, just sort of happened. All right, there's your vertical asymptote. The degrees on the numerator and denominator are equal again, so the ratio of their leading coefficients is 1. There we go. All right, so now we got to see where the curves are going to land. You know, is it this way or is it this way? So find that y-intercept. You can do the x-intercepts too, but sometimes that's a little trickier. But a y-intercept, like everybody can get that. So plug in 0 for x, and the y-intercept comes out as -1. Okay, so I know it's going to go this way somehow. And it's got to approach that dashed line. So that means there's an x-intercept somewhere in here. So if I set the numerator equal to 0 and get an x-intercept, that's just going to be a -1 as well. So there's your curve. Kind of missed, so just make a bigger dot. So since this curve is down here, that means the second curve is up there on the right. Okay, last one of these, part D. Vertical asymptote at 5. The degrees are the same again, so it's that ratio. So a -2 over a 1 is -2. So your horizontal asymptote is down here. Okay, if I plug in 0 for x, the y-intercept comes out as 0. So I've got a curve going just like that, which means my second curve is down there. And that's it for that one. Okay, so you're going to be expected to graph things like just like this, nothing like more complicated really, even ones with obliques. That's going to be saved for calculus. So I'm not going to ask you to graph those, but you still got to be able to know how to find them. So like for example 2, that's just determine any asymptotes. Then use a graphing utility to graph the function. Again, I'm not going to ever ask you to graph something like these on an exam or a quiz, but it's just kind of fun to see what they are. So just when you're doing this, pull Desmos out and graph them just so you can see what they look like, because they're kind of cool. All right, so we've got vertical asymptotes right at plus and minus 2, and a horizontal asymptote right at y equals 0, because the denominator has a bigger degree than the top. Okay, part B, I've got a vertical asymptote for sure, but the numerator is 1 degree higher than the top, so I've got that oblique asymptote again. Okay, so using the synthetic division makes the denominator a 0, a 2. I'm going to put in my coefficients, so 1. There's no x term, so I got to put a 0 in its spot. I have to put a 0 in as a placeholder, and then the -1. And I can do the division. So drop the first number, the 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. And -1 plus 4 is 3. So I've turned that function into x plus 2 plus that 3 is the remainder. So there is the actual division. So I have a vertical asymptote right at the positive 2. And then I've got an oblique asymptote at the linear part of that division answer. So just cover up the fraction, and what do you have left? X plus 2. And there's your oblique. Okay, so that is it for 4.3. So again, just be able to graph things like this, but you got to be able to find asymptotes of any type of function I can give you. Okay, so try the homework and let me know if you have any questions.